All right. Hello, everyone, and welcome to the fourth episode of SPIRE Baia Mare webinar series. Today, we will focus on reclaiming polluted brownfields through nature-based solutions, and we will do so with a very distinguished panel of international experts from both the professional and the academic fields. We will have, in particular, today's speakers include Ferber and Cundy and Anja Enell. Uwe is the managing director of StadtLand GmbH in Leipzig, Germany. With a background in environmental and spatial planning, Uwe's main areas of work include urban and regional development projects, European research and cooperation projects, and today it will discuss about managing brownfield land in stagnant land markets. Andy Cundy is a professor and director of internationalization at the School of Ocean and Earth Science at the University of Southampton at the UK National Oceanographic Center, and today it will present about brownfields to greenfields, benefits from phyto-management strategies. And last but not least, Anja Enell holds a PhD in chemical engineering, and currently she works as an environmental chemist at the Swedish Geotechnical Institute in Linköping in Sweden. And today she will present about risk management and regeneration of brownfields using bioenergy crops. And of course, presentations will be followed by a panel discussion with SPIRE's local partners, including Anca Plesa from the USAMV-Cluj Napoca and Tihamer Sebestyen from the green energy clusters, as well as with members from Urba Sofia, which is the company that I do represent, as well as possibly from the municipality of Baia Mare. And ultimately, we will also host Q&A sessions with the audience that is, as I was saying earlier, is able to raise their questions both through the chat box that we will constantly monitor, as well as by using the raise hand tool during the Q&A sessions. And now, before I leave the floor to the speakers, I just wanted to give a very quick introduction to our project SPIRE. And SPIRE Baia Mare is a smart post-industrial regenerative ecosystem, and it is Baia Mare's urban innovative action project that aims at fostering the transition of Baia Mare from the former mining capital of Romania to a leader of environmental design and production through a co-development of a new adaptive ecosystem with cascading material and energy value chains, also supported by a local digital value system. So here you can see that we will expect different phases, and of course we're now starting the phytoremediation and landscaping phase that aims at, of course, renaturing and remediating and bringing back to usability the plots, but also to trigger a process of circular economy for the upcycle of biomass. And in the long term, of course, we're gearing towards potential new uses as long as a long-term remediation and the land is available for future urban developments. So now, without any further ado, it is my real pleasure to give the floor to our first guest, Uwe Ferber, who will present his work on managing brownfield land in stagnant land markets. Uwe, the floor is yours.
Thank you very much, Pietro, for inviting me. It's a pity that we couldn't come physically to place and look at the situation and discuss not only over the day, also in the evening, a little bit larger about the brownfield topic. In the preparation of the conference, we discussed what is the focus of the session and of this webinar. And my turn is really to show a little bit a larger view on the topic of brownfield regeneration from a European-wide perspective. And next slide, please. And you will see that I make first some remarks about the definition and typologies of brownfields. What is the context in the European development and cooperation of brownfields technologies and brownfield strategies. And I will try to present you very shortly the circular land management and ABC model, because these are largely the discussed intellectual models, how to deal with a large complex problem of brownfields in the different regions. And last but not least, I will show you two examples from biomass production, which is not really linked to the contamination issue, but also linked to the idea to have a management approach with the most difficult polluted brownfield situation in structurally weak regions, which are not in the focus of the dynamic growing economic capitalistic markets. Next slide. So what is the definition? It's the reason why I give you the definition of brownfields is that sometimes we have some misunderstanding what are the real the situation of brownfields. And this is a definition which have been agreed at the European level in the core project of Cabinet. Cabinet project was a network of nearly all European countries, practitioners and scientists. And the brownfields is the definition they decided is that brownfields have been affected by former uses. Former uses don't mean automatically industries. This could be all types of different uses. They are derelict or underused. So in some sense, we have some fluid, the difference from totally abandoned houses to underused areas. And what is very important, they may have real or perceived contamination. So not all brownfields are definitely in a purely contaminated sense and status. They may have some problems with foundations, with infrastructures, pipes, and but also they may have large decontamination problems like old cokeries. So there's a large spectrum, but I will show you some pictures later on that this spectrum is really in a different way to regard in terms of strategies. Mainly the brownfields are in urban areas. This may be in different in the different countries. But what is very important is all brownfields need, in some sense, requires the intervention to bring them back to beneficial use. So, and as the other way around, if you do nothing, probably nothing will happen. And this is a very important state because when you do nothing and you have the chance to do it in the current IG funding period of the European Union, you have definitely a windows of opportunity to change the situation, but you must do it actively. Don't wait too long because the markets are not always active. Next slide. So as I mentioned, the brownfields have raised up in the European Union largely in the 1970s, 1980s years with the crisis of coal and steelworks, cokeries and textile industries. This was the first generation of brownfields, but at least at the 90s, we have the second generation, which large sites of military use, railway, abundant railway, social infrastructure. And on the right-hand side, you see one brownfield as we regard also the abandoned housing stocks. So housings which have mainly nothing to do with contamination are also in some sense brownfields because you need to intervene, to need to act, to do something to bring this back into beneficial use. Next slide. So what is the principle of brownfields? Normally say, okay, we have a brownfield, we need to bring it back into use, but in the ideal way, the brownfield regeneration, the activities are integrated in a strategy, which is a circular land use management strategy. So it's a current discussion about circular land management, circular economy. We also must include the land. And in this system of circular land use management, you have all types of strategies, including the planning of areas for abandoned sites, but also for sites which are still in use. We have the phases of brownfield status in the bottom of this slide. They have also perhaps specifically in economically weak regions the option to get into interim use options to find some 10 or 15 years uses opportunities to bring it back to the market. And we have the cycle management to reintroduction. What is important, brownfields policies are also have also the aspects of economic background, funding, of taxations, of different economic drivers and so on. They have the environmental aspect, which is the main focus of your project, but don't forget the social aspects. The brownfields are, in some sense, very negatively in the appearance for the whole city, for the regions, and in some sense, they're always a sign of decline. And so, as I mentioned before, it's very important to come over and to bring it back into use. Next slide. So back into use, it's a simply said opportunity, but as you mentioned, we have different types, and the strategies, depending how to bring brownfields back into use, are depending on different types. And this graphic you see on the left-hand left-hand side, the land value for brownfield reclamation after reclamation, and on the right-hand side, you have reclamation costs. So let's take the examples. You have a contaminated sites with cokeries or with heavy metal pollutions, and you have a not very dynamic market, and the property prices are around 10, 20, 30 euros per square meter. So in this type of C brownfields, definitely you are in this category C, where you don't have to expect that the private market will come and pick up your brownfield and put some activities. In the blue side, on the other hand, you have the self-developing sites. So let's say even in structurally weak regions, if you have supermarkets or some very attractive uses which have lots of pence or euros in their pockets, and in this case, maybe you should not even give public funding. You should perhaps just control development, ensure that this decision is very cool and soundly involved in your general development strategy. So you have these A projects, which are self-driven projects. So don't put public money in A projects. And as a B sector is also a very interesting sector, because when brownfields projects starting, you never know where they're ending, because the risk and potential of risk inside of the project development is very high in the phase of project preparation, planning, development. You could discover new contaminations, you could discover restrictions because of excess infrastructure. So you never know how you're ending. So you have in all categories, you have in principle 3 strategies. The A strategy of brownfields is to control and to let private investment in self-developing sites. You have the strategy in B to ensure that public-private partnership and the cooperation with the developer is ensured, and you minimize the public money. But, and this is very important, the C sites definitely require public investment, and probably they are far, far beyond any self-redevelopment phases in lots of regions. Also in Germany, in Saxony, my region, we have several C sites. Next slide. And this slide just shows the difference between growing and shrinking regions. So let's take the situation in Frankfurt, where Pietro is based. Most sites in Frankfurt, which are brownfield, have definitely no need to get with public funding. They are in some sense self-development, so largely depend on the framework of private sector. But in our region in Saxony, for example, in peripheral areas, where we have lignite or industry brownfields, most of the sites are completely depending on public investment. And then it's depending also if you decide towards a new investment for resettlement, or if you maybe also give the option to get into a green option or into the interim use option. Next slide. The next slide shows the example of the city of Chemnitz, where we mapped the total amount of brownfields, and you see in the green, in the blue colors, the increasing and big amount of brownfields, also partly used areas, but mainly they are under the definition of brownfields, over 530 mapped areas, overall 350 hectares, and 44% of the area of Chemnitz. And in the context of a city which is losing around 20% of population and which is actually shrinking. So it's not a question of redevelopment, it's a question to find opportunities to deal with shrinking markets and a brownfield situation, which is far beyond being the situations that the market needs this space for redevelopment. But maybe also for Corona times is this opportunity, because we know that green infrastructure is also a big opportunity for cities to get in a very attractive way. And this is a really opportunity also for the cities like Chemnitz to bring green infrastructure in the sites. Next slide. So the green infrastructure topic is a link to the topic of your seminar and workshop. And we are convinced that in large amount, the idea to redevelopment brownfield is an opportunity for green infrastructures. And as we know, it's very hard to convince municipalities and decision makers in towns and cities to create green infrastructure because this costs money. So it's nearby one option also to find solutions which are on one hand side cost efficient, which are reducing the cost for reclamation. And this is definitely the topic of the next interventions with decontamination with nature-based solutions. And the second option is also to use brownfields for biomass production, production on brownfields. We have in Germany two pilot projects. One is in the city of Gelsenkirchen. It's an old mining area for infrastructure, so railways for mining. And on this side, the Ruhrkohle is trying to grow crops with high energy potential for brownfield uses. And this is a plan to do it for the next 15 to 20 years. So it's not definitely excluded that 1 year this may be a new industrial site or housing site beyond this place, but actually it's a biomass production. On the right-hand side, you see the city of Halle near to Leipzig, which is also with experimenting on brownfield housing sites, so not contaminated, with fast-growing crops. And the first, in 2 words, say the fast-growing crops are growing fast, but are depending that the user of this crop wood is nearby. So if you take into account large transport chains for using this wood energy, it's not energy economic viable. So we are experimenting very intensively with different options, but the strategy behind is really to find an option for this type of seasides, to integrate them into green infrastructure and to minimize the costs for maintenance by bringing some beneficial production of biomass in the area. Next slide. So perhaps in giving you some definitions, some typology, and some strategies, I would just mention what is the current situation regarding the background of European funding in the next phase of 21-27. And we in Saxony, you see on the right-hand side the Brownfield program logo of the regions of Saxony. So the region of Saxony decided since 14 years, so since 2 funding periods, to fund over ERDF practice brownfield redevelopment. And we are prioritizing the project development for green infrastructure. This has 2 reasons. One reason is because of the shrinking situation. We don't need so much land for development. And the second reason is definitely with the amount of money given by the European Union. We have 56 million in 7 years. We are able to do much more projects with green infrastructure, with greening sites and interim uses and biomass productions. And this would be the case for industry areas or for housing areas. We are also in the context of the Leipzig Charter, which have been decided by the European planning ministers last year. And if you have a regard to the principles of the urban development in Europe in the Leipzig Charter, you see very prominently also the idea of circular management, of revitalizing cities and regions, and also green infrastructures are very highly on the agenda. And we are expecting also at the European level that inside of this regular European funding in the next years, around 8% of this funding will be designed to urban issues. And this is depending on every partner, also for Romania, Poland, Germany, that in each region you have to decide yourself in negotiation with the Commission, how would we spend this 8% for urban dimension, and would this be spent in new roads, new infrastructures, or also in some extent to brownfield and greening and brownfield redevelopment. And last but not least, please take care what is happening in the research areas. The New Horizon Europe program is also very intensively focused on the issue of sustainable development, brownfields, and in the context of urban-rural partnerships, also the relationship between the inner urban areas and the surrounding areas. And so in the total, we have 3 different working fields, playing fields, where we are quite optimistic that we could support also our component brownfield. But it's in the most time, not only a brownfield topic, it's an integrated topic of brownfield redevelopment inside of integrated development strategies with some clear documented issues and principles. So I think this was the last slide. Yes, thank you very much. This was very short, a very short overview. You could see in the slides some internet links, and I think if you have questions, please put it in the chat. And if not, you could contact me by email, and we could stay in contact. Thank you very much.
Thank you very much, Uwe. That was really an interesting perspective, seeing how the window of opportunity is open at the moment, but we need to seize the opportunity because the windows may open according to the market needs and wills. And thank you for showing the ABC model, which is actually a model that we analyzed in our studies, and we put it in one of our deliverables, as well as, of course, for showing us this case studies and further perspective for work. And now it is my pleasure to give the floor to Andy Cundy from the University of Southampton, who we will discuss about brownfields to greenfields, benefits of Phyto-Management strategies. I don't know if Andy's camera is working or not. If it is not, I am just showing you his face as he requested, so you can associate a voice to an image. And now, Andy, please, the floor is yours.
Thanks, Pietro. Hopefully you can all hear me okay. Apologies for the lack of camera. My bandwidth is insufficient. Maybe this is a pre-Brexit issue. My bandwidth is insufficient to actually connect the camera. So what I'd like to do is to present today a talk that builds on the brownfield and green infrastructure concepts that Uwe presented in his talk. I'd like to talk about brownfields to greenfields, how we can realise wider benefits from practical contaminant phytomanagement strategies. And as part of this talk, I'll cover the idea behind the concept of phytomanagement as opposed to phytoremediation. I'll also talk a little bit about the EU GREENLAND project, which ran earlier this decade, success stories and integrated management tools that were developed in that project. I'd also like to introduce some integrated phytomanagement systems we've been working on recently in the USA and in Colombia in South America. And then finally, some recent work on identifying the benefits, including sustainability linkages. That was a concept developed in the earlier Ombre project that I know Uwe was a core part of, and also waterfront brownfields. And then I'll give some concluding thoughts. So just to note that a lot of the concepts I talk about today have been published in Journal of Environmental Management. You can see the reference there, but I'll also talk about some more recent work which is about to appear in the Journal of Cleaner Production and other sources. Next slide, please. Okay, so phytoremediation. This has been defined in earlier webinars as part of this series. The definition here is phytoremediation is the use of living green plants for the in situ removal, degradation, and containment of contaminants in soils, surface waters, and groundwater. And this can be considered what we term a gentle remediation option, or more traditionally called a large area, low input solution. So here we're using the term GROW or gentle remediation option. These are risk management strategies or technologies that result in a net gain or at least no gross reduction in soil function, as well as achieving effective risk management. And they're very well orientated for redevelopment of urban and other brownfield sites for soft reuse, including biomass. Next slide, please. Okay, so the central concept of phytomanagement is that phytoremediation approaches can be applied as part of wider risk and land management strategies, either applying them alone or in combination with other remediation techniques, to gradually mitigate or eliminate contaminant-induced health and environmental risks. So risk management is at the core of this, but importantly, while simultaneously realizing economic ecosystem service and other benefits. So essentially what we're doing here is looking at the use of phytoremediation to break the contaminant linkage, okay? So to provide a risk management solution for contaminated sites, either through removing the source or breaking the pathway in order to protect the receptor, but also to realise wider benefits. So next slide, please. And so this is a kind of general model that we presented in the earlier Journal of Environmental Management paper. And really, this is what phytomanagement is all about. It's about managing risk using plants and other technologies, but in particular to realise wider benefits. These can be leisure and recreation benefits, economic returns from biomass, ecosystem service benefits, flood protection through the generation of permeable rather than impermeable land surfaces, health benefits, and also carbon sequestration benefits. And the key point about phytomanagement is that it places realization of these wider benefits at the core of site design. So here we're looking at applying phytoremediation and other gentle remediation technologies as part of integrated mixed site risk management solutions, or importantly, building on Uwe's earlier comments on the land use cycle, or as part of holding strategies for vacant sites. Okay, so you're managing the risk effectively while you decide or secure funding for other site uses, or you can use them to provide economic leverage for site redevelopment. Next slide, please. Okay, so I just want to introduce some of the outputs from the Greenland project. This was a Framework 7 project that ran between 2011 and 2014. And this was a project looking at the gentle remediation of trace element contaminated land. So land contaminated with a range of potentially toxic trace elements such as copper, nickel, zinc, lead, and arsenic. And the Greenland project coordinated data collection from a range of long duration grow gentle remediation option pilot projects at contaminated sites across Europe, as shown in the map on the right of the slide there. It evaluated standard protocols and methods for site monitoring. And for our purposes today, an important point, it developed a set of specific design aids for use when phytoremediation and other technologies appear to be a viable option, to promote the appropriate use of gentle remediation options, and also to encourage participation of and inform stakeholders. Next slide, please. So as part of the Greenland project, we developed a decision support framework, which was a simple Excel-based decision support tool. The decision support framework was designed to integrate with national contaminated site assessment guidance, where you undertake a site risk assessment, followed by options appraisal, and then implement your remediation strategy as shown on the right-hand side of that slide there. Within the Greenland decision support framework, we had a 3-phase model that fits in at the options appraisal stage. So phase 1 was to explore initial concepts and feasibility, to just check really whether gentle remediation is an option for your site. So within this, we had definitions, contaminant matrices, and examples of practical field scale grow application. Phase 2 was very much a more detailed exploratory stage or confirmation stage, where we talked about stakeholder engagement strategies and provided guidance on that. Included a sustainability assessment protocol developed by the EU Ombre project, and also produced some outline cost calculator modules in terms of working out your local supply chain and distribution chain in terms of whether it would be an economically cost-effective option. Finally, in phase 3, design stages, we presented technical assessment of the validity and application of phyto and other technologies, and also operating windows. So these are conditions under which the techniques or remediation techniques operate at their optimum level. Next slide, please. So this was a phased approach, providing operating windows, sustainability, including wider benefit and cost assessment, technical guidance, and success stories. And the success stories were kind of at the center of the decision support tool. This is one example shown there from Freiburg in Saxony. So such pilot scale applications of effective growth strategies, i.e. success stories, are key in providing robust technical and practical data for grow implementation, but also importantly in giving confidence to stakeholders, both in terms of illustrating long-term risk management potential of grow, but also in showing how wider economic, environmental and societal benefits can be realized. Next slide, please. So we were aiming to produce a practical, usable tool to interface with existing decision support tools and national guidance. And the aim was that the guidance could be used to support site planning, options appraisal, stakeholder engagement, and consideration of initial design scenarios, but also importantly, wider education on the potential risk management capacity and economic, environmental, and social benefits of GROWs. And that tool is available on request. So if anyone wants a copy of that, please feel free to email me and I will provide that. Next slide, please. Okay, so building on the Greenland project and particularly looking at phyto-management with wider benefits, this is some more recent work that we carried out in collaboration with the Argonne National Laboratory in the USA. And this is looking at the phyto-management and wider benefits in terms of an integrated system. So this was a carbon tetrachloride contaminated site in Nebraska in the Midwest USA. And at this site, the US Department of Agriculture recommended an integrated remediation system. So the problem here was carbon tetrachloride contamination in shallow groundwater that was the result of essentially pesticide spraying on a former grain store on a former US Department of Agriculture facility. So that carbon tetrachloride was used as a pesticide, and then it found its way to groundwater and was reaching a local stream, which was the risk management compliance point. So an integrated remediation system was applied here, consisting of 3 elements. Closest to the source, an air stripping element where groundwater was pumped out and essentially used to water some school playing fields. The idea being here that the carbon tetrachloride would be gradually volatilized to atmosphere and diluted and dispersed. The second element was a phytoremediation zone, and the third element, a set of constructed wetlands. A constructed wetlands designed to effectively polish the groundwater, reduce the contamination down to below the federal standard of 5 micrograms per litre carbon tetrachloride. So the idea here was to reduce the carbon tetrachloride concentrations in groundwater and protect down gradient surface waters. Next slide, please. Okay, so this was a greater than 10-year monitoring program carried out, led by the Argonne National Laboratories, of surface water, groundwater, air and vegetation samples. And so the diagram on the left there shows the gradual decline of carbon tetrachloride in micrograms per litre over time, but also as you pass through the phytoremediation component. And based on the data we have, it's estimated that the phytoremediation component removes 300 to 600 grams of carbon tetrachloride annually. And there's overall been a 99% reduction in carbon tetrachloride discharge to surface waters. So what we're particularly interested in here, though, as well as the risk management, was the wider benefits. And so this site's quite clearly delivered wider carbon sequestration benefits. Particularly we've estimated carbon sequestration of 77 tonnes per hectare per year in the phytoremediation component. Increased floral species richness, so between the trees there's been a mix of local wildflowers seeded, which are now growing effectively, and this is essentially in an agricultural prairie area. Okay, so very low biodiversity. This is a hotspot of higher biodiversity. Community participation and education benefits. This site is used as a living classroom by local schools as well. So very effective, if you like, leveraging of wider benefits coupled with risk management. Next slide, please. Okay, so here an example from Colombia, South America. At this site, we're funded by the UK Foreign and Commonwealth Office to look at solutions for mercury contamination in artisanal gold mining sites. At these sites, mercury is used to remove the gold and essentially then leaks out into the surrounding environment. So the aim here was to apply a soil amendment coupled with biomass strategy. So the idea essentially is phyto exclusion or in situ soil amendments. So we stabilize mercury in the soil with soil amendments and then establish a vegetative cap of green cover or biomass. So the idea here is to provide environmental and health protection benefits, but also generate a local income source through the biomass. but also to sequester carbon dioxide and provide other benefits. And the diagram here, the graph shows quite clearly that even with quite low percentage amendment application, we see a large scale reduction in the water extractable mercury at the site. So the mercury is effectively being locked away by biochar, in this case, the biochar provided by Secure Solutions. So again, we've got an example here of a kind of integrated technique where in this case, we want to lock away the mercury and then essentially grow a green cover or biomass on top of the sites. Next slide, please. Okay, so recent work, identifying and comparing benefits and disbenefits and waterfront brownfields. Again, I know that Uwe's provided a link to the EU Ombre project. This sustainability linkages approach draws on that project, particularly the work of Paul Bardos and colleagues, to look at the idea of sustainability linkages for assessing and comparing different scenarios for brownfield regeneration to soft reuse and other endpoints. So a sustainability linkage essentially is shown on the left there. It's a driver and a receptor via a mechanism. So this uses the SURF Sustainable and Remediation Forum criteria, sustainability criteria. And these are both benefits and disbenefits. So health and safety risks, material excavation and handling on site, site workers, driver, mechanism, receptor. That's a disbenefit, a health and safety risk. At the bottom there, we've also got a benefit, increased sense of pride or place, improvement of the urban landscape, removal of blight, receptor, the local community. So this operates in a similar way to contaminant linkages, but these are termed sustainability linkages. And in a stakeholder-led process that we've presented in a number of papers now, these can be integrated in a conceptual site model for sustainability. And that can assist in making individual cause and effects change explicit, and also allows different management options to be more readily compared and different linkages more explicitly valued. The example on the right there that we've published on is a waterfront brownfield in the Mersey estuary at Liverpool in the UK. And this is a site that was a former coastal landfill that's been regenerated to urban parkland. And we're assessing that site for sustainability linkages to look at benefits of that regeneration approach versus a standard control and maintenance approach. This is an interesting site. It's got a number of wider benefits. Large-scale local community involvement. It's managed by a local group, Autism Together, and the idea there is to get excluded or disadvantaged individuals from the local community into work and managing that site. Next slide, please. Okay, so concluding thoughts. I'm aware I've covered a lot of material there. I'd welcome any questions at the end, but there is, what this work proposes is a refocus from phytoremediation to wider phytomanagement based approaches. And these place realization of wider benefits at the core of site design. The combination of grows with renewables for biomass generation, this was a point picked up by Uwe and introduced there, but also with, for example, wind and solar power, as evidenced by a number of case studies currently in the US, can provide a range of economic and other benefits and potentially support the return of low-level contaminated sites to productive usage. And it's not just about large brownfields. You can combine grows and phyto techniques with urban design and landscape architecture. You can integrate them with sustainable urban drainage systems and community gardens. And that's got large potential for triggering grow application and in realizing wider benefits in urban and suburban systems. Identifying these wider benefits and their value significantly is going to be important, though, in leveraging funding and engaging local stakeholders. You need to clearly show the benefits for grow application and soft site end use more widely at vacant or underutilized sites. Next slide, please. Okay, thank you for attention. A whistle-stop tour there, and I'd welcome any questions. Thank you.
Thank you. Thank you very much, Andy. That was really interesting to also to see this new approach, not only phytoremediation, but phytomanagement as an integrated approach towards using gentle remediation options in many potential uses, in many potential in-between uses before we actually get a fully remediated site, but then we can achieve ecosystem services as well as other more social and economic impact. Meanwhile, we're pursuing further long-term goals. So it was really interesting to see also so many case studies across the globe. And now I will just move on to Anja Enell from the Swedish Geotechnical Institute, and she will discuss about risk management and brownfield regeneration with bioenergy crops. So again, taking this topic of management of the sites with the brownfields, with the regeneration topic together, and of course with productive uses such as the one of using bioenergy. So Anja, please, the floor is yours.
Thank you very much. Before I start my presentation, I would like to acknowledge the co-authors of this study. Professor Yvonne Andersson Sköld, who works at University of Gothenburg, Jenny Westin, who is a colleague of mine at the Swedish Geotechnical Institute, and Malia Wagelmans, who works at Bioclear, Groningen in the Netherlands. And this next one, please. This study was part of a bigger project called Rejuvenate. And Rejuvenate was about crop-based systems for sustainable risk-based land management for economical marginal degraded areas. And it started in 2009. And it was divided into two phases. So phase one developed a decision support tool for sustainable management of contaminated marginal land. So it was a decision support tool that could help you to choose the right crop for a specific site. And then in the next phase, we applied this decision support tool to different demonstration projects. And I'm going to present two of these demonstration projects to you now. The partners of this came from Belgium, the Netherlands, Romania, and Sweden. But the study that I will present now was conducted in Sweden, and we did this in cooperation with Bioclear. Next one, please. So the study has been published in the Journal of Soils and Sediments, so you can find it there if you are interested in more details, and it was entitled Risk Management and Regeneration of Brownfields Using Bioenergy Crops. Next one, please. And the purpose and the aim of our study was to show the potential of using phytoremediation as a cost-effective in situ alternative to conventional technologies for remediation of contaminated brownfields. And actually in Sweden, it is still common to use the dig and dump technique to excavate contaminated soil and then transport it to a landfill. And this is not sustainable, so we wanted to show that phytoremediation could be used instead. And in more specific terms, our aim was to investigate both the benefits and the potential risks with using phytoremediation on brownfields. We wanted to use a crop that could both be used for or could be used for bioenergy production. And we wanted it to be stabilization and not accumulation phytoremediation technique. Next one, please. So we conducted two field trials with willow, one in the northern part of Sweden and one in the south. And both of these brownfields were expected to have elevated heavy metal contaminants at the sites, but it turned out that there were no elevated levels of heavy metals at the field trial B in the northern part of Sweden. So we have been focusing most on the field trial A, which I'm going to give you details about. So at the field trial A, we performed an ecological risk assessment at the site before we did any cultivation, and then after the cultivation. And we followed the growth for 3 growth seasons. Next one, please. So, giving you some materials and methods for this field trial A. The site was an abandoned industrial landfill area where slag from metal industry and soil fillings from excavation works had been dumped. So we used approximately 30 times 40 meters area and we divided this area into 9 squares, which we examined by using a tool called XRF, where you can screen for metals. And we found elevated levels of chromium, copper, nickel, lead, and zinc. So we continued and took soil samples from these squares and performed chemical analysis. Next one, please. So here you can see the result of that. And it turned out that we only had elevated levels of copper, lead, and zinc. You see these in red. They are above the Swedish guideline values for less sensitive land use, which is a guideline value set for protection of 50% of the soil species. And some of the squares were also clean. So for example, number 7, we could use as a reference sample because it had concentration that was close to the background or below background concentration that can be found in Swedish moraine soils. Next one, please. So in our investigation, we used the squares here, 2, 8, 5, 9, and 4 as samples, and then we used our number 7 as a reference to compare these samples against. Yes, next one, please. So we started our cultivation in 2010, and we used 2 different hybrids of willows. One was a Salix clone called Inger, which we used here in the southern part at field trial A. And then we needed to use another one called Clara in the northern part because the climate is pretty harsh up there, and we needed a Salix that could cope with a colder climate. Next one, please. So when we revisited the site in 2011, so this is the trial A in the southern part of Sweden, we discovered that it had been a dry summer, and also we had a weeding problem. So we wasn't that successful with the growth rate of this Salix, so we had to do a new plantation of over 800 new cuttings, and this is what you see here in the pictures. Next one, please. So then in May 2012, it began to grow. And next one, please. In September the same year, we had actually big trees of Salix. So we could sample leaves. This was done in 2011, 12, and 14. And then we also took samples of twigs in 2012 and 14. Next one, please. Okay, for the environmental or ecological risk assessment, we used something called a triad approach. The triad approach is actually now an ISO standard, and it's a method for doing 3 lines of evidence, where you have one chemistry line of evidence, one for ecology, and one for ecotoxicology. And you could weigh these 3 together into one integrated risk estimate. And you could use several different tests and methods for chemistry and ecology and toxicology, but we just used one for each. So if you please click and one more time and one more time, you can see what we used. We used soil concentrations in the chemistry line of evidence. We performed an ecotoxicity test called the microtox test. It's also a standard. And then we also studied the population of nematodes in the soil. Next one, please. And by using this triad and calculate these integrated risk estimates, you get a value between 0 and 1. And what you actually do is that you compare your samples to the reference sample. So the reference sample is 1 or is close to 0 or actually 0, and this indicates no risk. And then if you get a value of 1, this indicates a very, very high risk, and then you can get values between there. Next one, please. This is just a picture of the lysimeters that we installed, and these were used for sampling pore water samples. We installed several of these at each sample spot, so we could take composite samples. And it's a very easy technique where you just use a syringe to suck up the pore water from the soil. Next one, please. The biota sampling was used to calculate the risk for grazing animals, and we wanted to calculate the risk for wildlife here, but we couldn't find any good values to compare with. So we had to use NOAC values for cows and acceptable daily intake for sheep to calculate a risk for bigger animals, where cow represent the bigger animals and sheep is representing the smaller animals. Next one, please. So now I will guide you through our results and discussion. We'll start with the ecological risk assessment, and then we end with some benefits from the biomass production. Next one, please. So here you look at the results from the triad method that we used. So in the first row here of the table, you have the lines of evidence from the chemistry, where we calculated something called a toxic pressure. Toxic pressure is also values going from 0 to 1, where 0 indicates no risks and 1 indicates a very big risk. So you can see here that we have values above 0.5 in the, for example, number 2, A2, and we had also high toxic pressure in A5 and followed by A4. But then there were low toxic pressures in the rest of our studied samples and also in the reference sample. The toxicity, back please, the toxicity tests that we used were not sensitive enough, so we didn't get any response, unfortunately. The population of nematodes deviated a lot from our reference sample, at least in the first sampling occasion. So before, for example, in point number 2 here, before before cultivation, we had an integrated risk estimate of effect of the nematodes of 0.58, but after cultivation for 2 years, it had declined down to 0.1. And this was the case for all the sampling points. They were declining or in the same range as before cultivation, indicating a better soil condition for the nematodes after cultivation. And the same trend goes for the integrated risk estimates, which you can see here on the second last row. Next one, please. So if we have a look at the soil pore water concentration, we saw a decline for lead in the 2 sample spots with the highest soil contaminants. And for the other spots, they were very close to detection limits. So we had rather low soil pore water concentrations here, also indicating no risks for spreading of these heavy metals from the site. Next one, please. And if we look at the concentration in the biota and the risk to grazing animals, and we start with the diagram to the right, we see the concentrations in the Salix leaves here. And as you see, we have high bars for October 2011, both for the lead here and the zinc. And we think this is just due to a very slow growth rate during this year because of this weeding problem and the dry summer we had. And others have also found that these metals can accumulate during such conditions. But all concentrations were actually low in the leaves, and when we use the maximum concentration in the leaves for calculating this risk quotients for cows and sheep, we saw that we have very low risks for cows. All values were under 1, indicating no risks. It was only for zinc and for sheep that we have risk quotient above 1. And when we recalculated using mean values, these values were also declining and indicated no risks. Next one, please. So if we go to the biomass production, we could see that we could, in the reference sample, we got 23 tons dry weight salix per hectare per year. And this amount declined with increasing toxic pressure. So it looks like when the toxic pressure is coming up, the soil couldn't produce so much biomass anymore. But this is actually not the case. We think this is more due to the soil condition at the sampling spot at 2 and 5, because we had more slug lumps and bricks, and it was a very compact soil compared to the reference sample and the other sampling occasions. And we also calculated the net gross income, and we saw that if you could produce above 5 tons per hectare each year, you will have an income that will be above the costs that you could have. So everything above 5 tons is good. And this was conducted in the southern part of Sweden. So we think that for Central Europe, that will be better conditions, and you could have a higher biomass yield there. But you also have to consider if there are any bioenergy producers that are willing to buy the biomass here. So we made interviews, and there were several in the region that were willing to accept our biomass, but they all questioned if there were any elevated concentrations of contaminants in it. And if there had been any, it would have been considered as waste, and then we would have a net gross cost. However, you can take next slide, please. Our environmental risk assessment clearly showed that these abundant, moderately contaminated industrial land could safely be used for bioenergy crop production by the use of phytostabilization. So the uptake of metals in the plant was really low, and the growth rate depended more on the soil texture rather than the contamination levels of these sites. We also showed that there were a low uptake from contaminants into biota, indicating a negligible risks for grazing animals. Next one, please. And the environmental risk assessment indicated lower risks after 2 years of cultivation. And we think that over a longer term, the risks are also expected to continue to decrease as a result of the way that cultivation improves the soil quality. I didn't show you that results, but we had an increasing amount of organic matter after a couple of years of cultivation in the soil. And the biomass production was high enough to provide revenue despite harsh conditions. So our study clearly shows that phytostabilization with bioenergy crops on brownfield has, besides the environmental benefits, potential to turn these areas from uneconomical into beneficial ones. Next one, please. This is my last one. This is just some lessons learned. What I think you should keep in mind if you would like to try this is that in order to succeed, you have to choose a relevant crop for that specific site. And hyperaccumulators can increase the risks for grazing wildlife, and it could also make so that the biomass will be considered as waste. So it's very important that you choose the right crop for the right site. And regarding the triad approach, if you we'd like to use that. It's very, very important to choose relevant ecological and ecotoxicological indicators for this. For example, our microtox test is not recommended. We should have chosen another test. In retrospect, I know that. You should also mind the natural variation and choose the reference sample very carefully. That we have learned. Thank you very much. I also would like to say thank you to the funders of the Rejuvenate project.
Great, fantastic. Thank you very much, Anja. That was really interesting, and we really funneled down toward the very specific case study, and this, I think, gives us two really important points of discussion. And one is the risk, of course, performing risk assessment ex ante and ex post, but also considering the life possibilities and the growth possibility of the plants in respect to where they're cultivated and with respect to the soil conditions, as well as the usability of and the amount, the kind of biomass and the amount of biomass that they will actually produce, because of course that is a really interesting point, that it can be a revenue, a usable biomass, but it can also become a cost when you produce further waste if you're not able to use it. So now I would be very happy to open the floor for discussion, and I would see if our partners from GEA or from the USAMV want to say something, or as well as if the director from Urba Sofia, Dr. Elise, wants to chip in with a comment. But I would possibly suggest that Anca Plesa makes from USAMV makes the first comment, and then we move to GEA. Anca, please.
Okay, I want to ask Uwe Ferber, Mr. He spoke about some planning, yeah, and economic aspects. Do he have an example of a cost, or how much does it cost to regenerate degraded and polluted land?
So the costs are varying depending on the different economic context, but in general, you could see the reclamation in Germany for the cost structures in Germany for conversion military sites, which have no munitions problems. The lowest costs are around 10 to 25 euro per square meter with any restriction of decontamination. On the other hand, you could have the extreme costs of 100, even 200 euros per square meter if you have to face quarries, heavy metals, oil in the underground, and so on. And in our program in Saxony, for example, we run in the one phase of 7 years in the average price of around 500 funded projects. The average price per square meter was around 65 euros. But let's say we focus very much on the brownfield and not on the contamination issue. So we refused to change use into housing areas, which would have increased very much the cost for reclamation to a much higher end of costs.
Okay, thank you.
Thank you. Anca, do you have other questions, comments for other?
Actually, I have one for everyone. Okay.
Please feel free to raise all the questions.
Okay, for Mr. Andy, in your example, you talk about stakeholder engagement, but were there in your project some where the authorities were involved and not the landowners, because he talked about landowners?
Yeah, that's a very good question. Really, the message from all of the case studies is that stakeholder involvement and engagement right from the beginning of the project conception is really important, and the stakeholders should be as wide a group as possible. So we've divided our stakeholders into core and more peripheral stakeholders. Certainly the landowner and the regulatory authority are key core stakeholders, but it's very important to involve the local population as well. The example from the USA, the Murdoch example, Nebraska, followed the US EPA guidance on stakeholder involvement, and they were very good initially at getting the local community on board and involved in the planning and the whole process. So I think the message is to involve the landowner and the regulator, but also to involve the local population. I know that's something that the SPIRE project is looking to do.
Mm-hmm. And what species do you use in your first example? Only salix, because you talk about species richness somewhere, and you said you improve species number. And
yeah, so the plants that we used, the trees that we used were mainly eastern cottonwood. These were native US trees. So eastern cottonwood, which is Populus deltoides, and also we use willow as well, Niobe willow. The biodiversity was very much focused on in between the trees. There were wildflowers and native vegetation planted. So this was in a prairie agricultural area, so very low diversity, and the trees were deliberately, the areas between the trees were deliberately seeded with native wildflowers to get almost a kind of meadow approach in between the trees.
Mm-hmm. Okay, thank you.
Yes, thank you very much. And maybe just let me, since my background is more on the co-creation, participation, and citizen stakeholders involvement, would you mind to say a few words more about the process of involving the citizens and letting them aware of the kind of process that you were carrying out and the scope and the potential of the phytoremediation, phytomanagement strategies, and so how you made to transfer and to explain this to the population and get them involved in the projects?
I can start on that one. I think a good example again is the Nebraska USA case study, where essentially they sent publicity to the local population, inviting their input. They held a series of town hall meetings to get local input in terms of their plans. And we've got a few examples where actually the kind of master design plan was presented to the local residents, and that after their comments, that was amended or improved to get more stakeholder engagement and stakeholder buy-in. I think that's really important for phyto-management schemes, because often compared to something like dig and dump or another more invasive remediation method, you're looking at a much longer term risk management solution, and you're essentially changing the land use, and so it needs that contact with the local population. So in the USA example, it was very much leaflets to local people, town hall meetings with the regulator and the landowners, and there was a stakeholder management group which engages stakeholders throughout the process, including in the monitoring phase as well.
Right, correct. And I think, Uwe, do you want to add something?
Perhaps 2 words to Andy. You have also this famous organization of groundwork and land restoration trusts in the UK, which supports very strongly stakeholder engagement, not only in the phases of building, also in the maintenance and long-term perspective.
Yeah, thank you. Anca, I think you also wanted to raise a question to Anja. Is it correct?
Yes, for
Please.
Anja, only if she knows about what depth did you take the soil samples for nematodes, for example.
Yes, for the nematodes, we used just 10 centimeters below the ground. And we also took other samples down to 30 centimeters for soil concentrations of the heavy metals.
Okay.
Yeah, because we also, and Anca and her team at USAMV did the same kind of testing in Baia Mare, if I am correct, or something similar.
Interesting. You could just contact me if you have any further questions.
Of course, and you only number them or
Pardon me?
just measure the nematodes?
We did several, we measured the population, the different species, the feeding groups, and we calculated the maturity index, if you are familiar with that.
Okay.
Okay,
Thank you very much.
I think maybe Tibor from GEA or Eniko from GEA want to add a few words?
Yes, thank you.
Please.
So thank you very much for all your presentation. And I remember when I've been living in the Netherlands, I visited several former military sites in Germany, and I also remember that they installed new how called this renewable energy facilities like solar panels and so on. Do you agree with me, Mr. Uwe Ferber? And yeah, I also remember that another scope of these sites were also the biomass logistic and trade center, if I remember correctly. But I want to ask you in your recent examples or work, how can you get permits in order to change from military sites into, I don't know how to ask, but you know, at least in Romania, if you have industrial sites or military sites, they have certain scopes or objectives of the sites from administrative point of view of the sites. In Germany, you should change this documentation, or it was easier to implement this project?
Yes, to speak frankly, the biggest problem in Germany is not to get over the permissions, and because when you have abandonance of military uses, the site comes back to the initial owner. In a lot of cases, the owner is the national government, and the national government administration is not very flexible, let's say, and in some terms based on the Ministry of Finance, and very interested to get the maximum of amount of money and not the maximum of beneficial use for the community or for the local authorities. So in terms, we have no problems with the planning change legally, but we have a problem of conflict between different ownership and institutional interests in terms of valorization of land. In our Saxony program, we took the opportunity not to change land use because most brownfields have been industrial or artificial, industrial sites, and we did not change the land use because in this case you avoid to start planning, and we just financed the demolition and the greening and the interim use, also perhaps biomass production, but under the status of commercial land. We did not change the legal status because the interim use was also accepted by the administration as an interim use. And you could say, okay, let's wait 15, 20 years later on, you could still change the status of planning. If you change status of planning, the costs will rise because then you have to decide what is definitive use. And you have to also invest in different standards for reclamation, but also in different standards for infrastructure. And this took much larger difficulties than the small level cost with the reserve sites and the interim use sites.
Okay, thank you very much. I had also other questions to Andy, but I received already the responses. And to Anja, Enell, how long took the monitoring of your project? You mentioned that you planned salix, and how long it was the project? I remember that from 2011 to 2014 was the some researches on soil and chemical components of the plant, but later on
Yes, for our project in the southern part of Sweden, we monitored for 3 growth seasons, so 3 years. But we are still having the site, but we haven't been doing any monitoring. But maybe we will come back in the future to do more investigations. But the site in the northern part of Sweden is terminated.
Do you perhaps have like any news of what's going on in like how's the site being used after, I think it's like 7-8 years after the end of the experimentation?
No one is really using it at the moment, so the salix is just growing there. It's very close to a recycling station where people come and recycle the stuff. No use at the moment.
Okay, good. Okay, so I just wanted to check if we have other interventions and other questions from the audience. Maybe from I've seen partners from the city. Maybe they want to raise other partners from SPIRE. Otherwise, I would try to wrap it up. Let's see if I see Anca that maybe has another question.
Okay, I don't know. Probably for Andy or for Mr. Uwe, in our project, we want to make the contaminated sites available for the public through landscaping. Okay, can you tell us some safety measure that we should consider? Or
yeah, no, that's actually a very relevant question because let me go back
strategy,
first.
you know.
Yes, yeah, I get your question. So let me get back for a second. So the idea for us is to start the phytoremediation on the pilot sites, which are very contaminated with lead and copper, if I'm not wrong.
Mm-hmm. Yes.
And of course, we want to start making them somehow usable and usable by the population, but we need to take some safety measures because they cannot, of course, work on those grounds as they are. But what can we actually do to allow the people to walk through and to use those sites as somehow parks or leisure areas? Meanwhile, they get remediated.
Thank you, Pietro.
Thank you.
I can
pressing question we have. And
Andy, it's your turn.
I'm happy to start with an example, Uwe, thank you. This is an example not from my work actually, but from some work that's been done in Bordeaux in France by Michel Mensch and colleagues there. And they were looking at regenerating a former naval site which was contaminated with heavy metals, and they designed urban parkland, and you can design the parkland where you can control the flow of people around the site through paths and also through whether you've got dense vegetation or less dense vegetation. And I suppose so that's quite a good example of effective site design to kind of control where the people go on the site. But the other areas we've been looking at are very much, you need to characterize the contaminated land very thoroughly initially. And we've been looking at examples where in some integrated land use, so in some parts you might have to seal the soil surface or put a membrane over it to stop people getting to the most contaminated areas, and then you have phytoremediation in the slightly less contaminated areas. So it may be that you need hotspot control in some areas and phytoremediation in other areas. It depends on the level of site risk. Sorry, Uwe, I'll hand over to you.
Yes, and perhaps one short complementary remark. So you need a good landscape landscape plan to avoid contact in terms of viability, but also in terms of contact with soil, so topsoil. And a little bit cynical, but also in this example I showed from Gelsenkirchen, this site have been contaminated, and this have been used over a period of 5 years as deposit for non-contaminated soil from building measures. So they put up let's say a stockage, the stockage of soil over a period, and they win money getting unused soil, topsoil and so on this site, and started the landscape project after on. So this is so I don't know the English word. In German it's zwei Fruchtfolgen. So they use 2 times the opportunity of a brownfield to bring income in the site.
Yes. That's great, because I think what is really behind this remediation, phytomanagement, is what you can do in addition to the remediation of the sites. And this is what, from an economical point of view, that's absolutely advantageous, because it takes off a lot of extremely costful operations that are the dig and dump, from the dig and dump approach. But they also takes longer. The trade-off is takes longer times, but in this time you can do many other things. And as Andy and Uwe and also Anja were mentioning, that we really have a lot of wider benefits while doing so. So let's say if we have other questions from the audience, otherwise it's almost time to wrap up. So I would like to ask a very fast 30 seconds concluding remarks from each of the speakers, starting in reverse order. So Anja, Andy, and Uwe, and then I would like to wrap up and conclude. So Anja, please, if you have like your final thoughts, please.
Thank you very much again for inviting me. It has been very interesting to listen to both Uwe and Andy. And I haven't been working a lot with phytoremediation since we done this project, so it was it was a pleasure to hear that the research is going on in Europe.
Yeah, thank you very much, Anja. Andy?
Yeah, I think just to echo those comments, thank you very much for inviting us all. I think I suppose my concluding comment would be there's some really good examples internationally of best practice on phytomanagement and leveraging wider benefits that I think the SPIRE project can draw on. But I think the work you're proposing is fascinating, and I wish you every success with it. I think over the coming years, SPIRE has the opportunity to be an international best practice example for others to learn from.
Thanks a lot, Andy. We drücke unsere Daumen. So we cross our fingers, and with my poor German quotation, I'll hand over to Uwe for his comments.
Yes, thank you, Pietro, for this interesting seminar and workshop discussion. We had not so much time to interact because of the digital format. Perhaps next time it's a real physical seminar. And please take into account the opportunities for the new funding period. Fight in your place in Baia Mare to get money for brownfields, but not only to get money, but invest it wisely and use the experience of failed and good examples in Europe in the last 20 years.
Yes, thank you very much. Indeed, this is really the scope of the urban innovative actions, is to experiment groundbreaking solutions, build synergies with existing projects. And so we are actually looking forward to develop further synergies and keep discussing with all you and developing possible partnership in the course of our project. And let me try, with my fingers crossed, to invite you for a further session to be developed in the redeveloped and renatured landscape sites in Baia Mare as soon as this will be feasible. So looking forward to seeing you all very soon. I thank very much all the speakers for joining us in this webinar today, as well as the audience to, of course, participate in today. And I'm really looking forward to the next steps. And please keep following us on through our social media channels, as well as our website. So thank you very much, and see you later. Bye-bye.
Bye.
Thank you. Bye.